Jai Bharat to all students. Last lecture we have discussed some of the definition related to the graph theory, and in last we have discussed this adjacency and degree. Okay, so in now today's lecture we also discussed some of the different definition regarding this chapter. Okay, in last lecture we have discussed what is adjacency and what is degree. Okay, uh, we said that two vertices V and W of graph are adjacent if there is an edge VW joining them. Okay, adjacent means near. Okay, they are near two vertices. Okay, so if edge is joining between these two vertices, that this is called adjacent vertices. And if its adjacent edges, then it link with the common vertices. Okay, if it is a adjacent edges, if they have vertex in a common. Okay, so E and F is edge. Okay, but it's adjacent edge, and here V and W is vertices but adjacent vertices. Why? Because one edge is joining between them. Okay, so this is called adjacent near. Okay, these two vertices are near. Okay, if let's say here one vertex is P, so we can say that P and V is adjacent but P and W is not adjacent. Okay, and degree of vertex. Okay, we already see that two times. Okay, degree of vertex V is the number of edges with incident with the V. Any vertices, number of edges with any vertex, and it's written as a degree of V. Okay, now if there is a loop, then we have to calculate degree of vertices as a 2 rather than 1. Let's just like say here it is a vertex P. If it say it's a loop here, so we have to calculate. This is a for degree of vertex, this is one edge. So how many edges are there? 1. And for loop we have to calculate 2. At 1 and 2 means 3. So for P vertex, degree of vertex is 3. But here for Q, degree of vertex is 1. Why? Because it's joining with only one edge. Okay, so if there are loops, then for this vertex we have to calculate degree of vertex as a 2. And any vertex of degree 0 is an isolated vertex. Okay, only vertex, no edges joining them, so degree of vertex is 0. And degree of 1 is called n vertex. Here Q is our n vertex. Why? Because degree of vertex is 1. Okay, now here this is n vertex, these two. Why? Because degree of vertex is 1. Okay, here also this is also degree of vertex as a 1. Here Z, so it's called n vertex. Okay, so figure 1.1 has a 2n vertex. Yes, 2n vertex, and 3 vertices of degree 2. This as a how many edges are there? 1 and 2. Here this vertex also degree of vertex is 2. Here also 2 and 2. Why? Because they have joining with 2 edges. Okay, and for this graph, okay, if we have to calculate for W, so how many edges are there? 1, 2, 3, 4, 5 and 6. Okay, so W has a 6 degree of vertex. For U, 1, 2 and 3. Degree of vertex is 3 for U vertex. Okay, you have to calculate for particular vertex. Okay, you do not have to calculate for all the graph. Degree of vertex is calculated based on only one vertex. For V, 1, 2, 3 and 4. 4 edges, but here they have calculated 2 loop. Okay, so here 2, 2, 4 plus 2 plus 6, 6 plus 2 means 8. Okay, for V, degree of vertex is here. So okay, you have to calculate loop as a 2 degree of vertex. Okay, whereas there is a loop, then degree of vertex for that vertex is called is 2. And if you want to write down degree of sequence, you have to write down in the increasing order. Okay, if there are repetition, you have to write down as a 2, like this. Okay, so we have first of all 1, and here also we have 1. Okay, so 1 1, then 2 2 2. Okay, you have to write down like this, increasing order. Okay, not first of all like this 1 2 2 2 1, not like this 1 1 2 2 2. If there are 3, then next we have 3. And for this figure, we have to write down 1, then 3, then 6, and then 8, increasing order. And if there are 2 same, then you have to write down 2 number. Okay, 1 1 2 2 2. Okay, like this. Okay, so degree of sequence. Okay, now one theorem is there, handshaking lemma. Okay, what is handshaking lemma theorem? Says that in any graph, the sum of all the vertex degree is even number. In any graph, the sum of all the vertex degree, okay, is an even number. Okay, let's calculate this is graph, and we have calculate the number of degree vertex. Okay, so sum, we can sum 1 3 plus 6 plus 8, 4 plus 6 10 is equal to 18. Okay, yes, it is a even number. Okay, so it's called handshaking lemma theory. Okay, why there is always a degree, sum of all the degrees vertex is even number. Okay, let's say here for this edge, here for this edge, how many edges are count for this vertex? For this vertex 1, for P vertex we have count these edges as 1 time. For this vertex we only have count this as a 1 times. Okay, so in any number this edges count is a 2 times for both the vertex. Yes, so all these edges is count 2 times. Okay, so if any edges, number of edges count 2 times, then if there are any number we can multiply by 2, then it's always is a even number. Okay, yes, the sum of all the vertex degree is equal to the twice the number of edges. Okay, why? Because edges is count as a 2 times. Okay, so since the each edges contribute exactly 2 to the sum, it's thus an even number. Okay, number of edges count as a 2 times. Okay, these edges count 2 times, one in vertex P, one in vertex Q. Okay, and also this edges is count 1 times in Q and 1 times in R vertex. Okay, so number of edges is equal to so number of vertex degree is equal to the 2 times number of edges. So it is the summation of all the degree of vertex is always have to become even number. Or why it is called handshaking? Because it tells us that if several people shake hands, then the total number of handshake must be even. Why? Because just 2 hands are involved in each handshake. Okay, so handshaking lemma is the following. Okay, number of head is always handshake and is must be even. Okay, because 2 people can make handshake. Okay, so in any graph the sum of all the vertex degree is an even number. Theorem 2, just like this theorem, in any graph the number of vertices of odd degree is even. Number of vertices of odd degree is even. Odd degree means 1 3 5 7. Why? Because they have to become in common to summation and will become even. If it is a, let's say 1 3 and 5, there are 3 number, then we have to summation. Then what is the number of 3 and 5? 8. So our summation will become 9. But our first theorem says any graph the sum of all the degree of vertex is even number. So in any graph the number of vertices of odd degree, not talking about even degree, odd degree is even in pair. Okay, so that their summation should always become even number. Okay, so this is a two theorem. Then next our subgraph. Okay, a graph H is the subgraph of graph G if each of its vertices belong to the V of G and each of its edges belongs to the E of G. Okay, so what is called subgraph? Subgraph means small graph of G. If H is a small graph, then all of its vertex and all of its edges belongs to the its vertices and edges to the graph main G. Okay, just like say this. Okay, this is a H graph, this is just say G graph. Okay, here these vertices they have 4 vertex. Okay, you can correlate with them. Yes, just like this. Yes, and they have number of edges is the same. Okay, so this is called H is a subgraph of G. Okay, you have to count the number of vertex and number of edges. Okay, okay, now here this is not a subgraph of this. Why? Because for this we have here we have triangle, but here we do not have any triangle. Okay, if there is a vertex is in center, then we have become the subgraph. Okay, but here just like this graph we cannot correlate with the main graph. Okay, so this is not a subgraph of this graph and this is a subgraph of this graph. Okay, small graph portion of a main graph. Okay, subgraph is called portion of a main graph. Okay, we can also obtain subgraph of a graph by deleting edges and vertices. Okay, if we delete some of the edges and some of the vertices of any particular graph, then we can obtain subgraph of that particular graph. Okay, just like says here we can we delete these edges, these vertices, these edges also, and this edges also, then what will become this graph. Okay, so we can say that this is a subgraph of that particular G graph. Okay, so if we delete, let's say I have delete these vertices. Okay, and say I have delete only these vertices and these edges. Okay, so this is also a subgraph. Okay, this is vertex, vertex, and vertex. I have deleted one vertex and 2 edges. Okay, this is also a subgraph. Okay, so we can obtain subgraph of a graph, any graph, by deleting edge and vertices. Okay, okay, let's say there is an edge E. Okay, for what in between vertex V and W. Okay, if we remove this edge, okay, so we can obtain GE. It is called a subgraph of that particular graph. Okay, we have removed the one edges E. Okay, so if E is edges of the graph in G, this is a graph G, so we can obtain G. We have to write down like this: GE, the graph obtained from G by deleting the edge E. We have deleted edge E. Okay, also we can obtain vertices GV. Here E is the our edge, but if we want to make delete the vertices, okay, we have delete this particular vertex, okay, and related to its edges. Okay, so we have related to edges is this. Okay, so we have now this and this. Okay, only this. Okay, this is also a subgraph of this. So sorry, G graph and subgraph, and we have to write down like GV. Okay, we have delete vertex in this graph, and we have delete edge in the graph. Okay, so this two is a subgraph of this particularly main G graph portion of the graph. Okay, yes. Also, we also donate G per E the graph obtained by taking an edge and contrasting it, that is removing it and identifying its end V and W, so that resulting vertex is incident with all those edges. Okay, let's see with a figure so we can get the better. Okay, this is a edge E. We can obtain graph G per E, so that we have to merge this connecting these two vertex with the edge E. Okay, we have connected V and W. Okay, so this point P is here. Okay, and we have make the loop in between V and W. Okay, we can make the loop between V and W. So this is a G per E graph. Okay, this is called G. So we have seen three types of different graph. GE, we have removed one edges. Here we have removed vertex, and here we have removed G per E, remove edge, and make connecting two vertices make as a one vertex. Okay, and our last for today's lecture definition is complement of a simple graph. You already know complement in matrix also. Okay, A dash, yes, matrix complement. Okay, so here we have also have complement in graph. If G is the simple graph with a vertex set V of G, its complement, write down like this, G bar is the simple graph with a vertex V of G in which two vertices are adjacent if and only if they are not adjacent in the G. So what this definition say? If there is a edge between these two vertices u y and u, so its complement do not have the edge between y and u. Okay, so what are the edges? If there is a no edge between G graph, main graph. Okay, so here you can say that for u vertex and v vertex we do not have any edge joining them. Okay, so for complement we have to connect these two vertices. Okay, so here also we do not have any edge between u, y and w. Okay, so we have connected them. Okay, here also we do not have the connection between x and u and x and v, so we have connected them. Okay, any same edges are not in complement. Okay, complements it's reverse. Okay, so in which, so let's write two adjacent. Adjacent means near. Two vertices are adjacent. These two vertices are adjacent if and only if they are not adjacent in G. Okay, here they U and V is not adjacent. Okay, what is the theory of adjacent? Adjacent means two vertices have to be have joining with one edges. Then these two vertices called adjacent. But here for a simple G graph, you can say that U and V is not adjacent. Why? Because there is no edge joining between them. So not adjacent in G and adjacent in G bar. Okay, so it's called complement. Okay, so in short, you have to draw complement like if there is a no edge in G and G bar. Okay, so here we have to remove this graph, this chair, and make any other adjacent edge. Okay, it's called complement. Okay, so now we have learned 4 to 6 definition, adjacent, and degree of vertex. We have to write down like this: degree of vertex. Okay, in increasing order, and for loop we have to continue calculate as a 2. This loop has a degree of vertex 2. Okay, for a degree of vertex 0 is called isolated, and degree of vertex 1 is called n vertex. Okay, then we have seen handshaking lemma theory. All the vertex degree sum is even number. Okay, then subgraph. Okay, subgraph means small graph. Okay, it's if vertex and edges are the same of between two graph, then it's called subgraph of this graph. Okay, you have to calculate edges and vertex. You can also make any subgraph from the graph that by deleting any edges and any vertex. If you delete edges, it's called GE. Okay, it is also a subgraph. If you delete vertex, any vertex, it's called GV. Okay, and if you make any edges remove and make that adjacent vertices as the same, then you can obtain graph G per E. Okay, we have merged V and W vertices and make multiple edges with this vertex. Okay, so it's called G per E. Then complement, you have to remove edges joining between two vertices, and if there is a no joining between two vertices, then you have to make edges. Okay, so it's called complement. Now if you want to this G bar, if you want to complement of this graph, so what graph will draw? This graph. Okay, so complement of G bar is always a G bar. Okay, so it's a complement of simple graph. Now here it is your today's assignment question. You have to write down degree of sequence of each graph with all are these 4 vertices, and verify that handshaking lemma holds for each graph. Okay, you have to verify that all the sum of the degree vertices is the even number. Okay, so you have to calculate for degree of sequence for this graph, and all the 6 graph, and you have to also calculate sum of all the degree of vertices is even number. Then you can say that handshaking lemma theory is true. Okay, so now here your today's lecture is completed.